You know, I've spent my entire career looking at the cosmos. I've stared into telescopes that pierce the veil of space and time. I've held meteorites in my hands that came from the very edges of our solar system. I've spent countless nights contemplating the impossible, wrestling with the unknown, and asking questions that most people never dare to whisper in the dark. But every now and then, something comes along that makes even seasoned scientists pause. Something that forces us to reconsider what we think we know about our place in the universe. That something is the 3i Atlas. Now, before you close this tab or scroll past, hear me out. This isn't about ancient aliens or wild conspiracy theories. This is about real geology, real physics, and some genuinely perplexing observations that deserve serious scientific inquiry. And frankly, that's far more interesting than any fictional narrative we could construct. Let me take you on a journey, from the mundane rocks beneath our feet to the possibility that we might be sharing our planet with evidence of something far more extraordinary than we ever imagined. In 2019, something remarkable happened in a place most people would consider utterly unremarkable, a remote quarry in southeastern Kazakhstan. A team of miners, going about their ordinary work of extracting limestone, made an extraordinary find. Buried within layers of sediment that had been accumulating for millions of years, they discovered a stone that looked like nothing they'd ever seen before. At first glance, it seemed almost mundane, roughly spherical, covered in a peculiar crystalline coating, approximately 47 centimeters in diameter. The sort of thing you might glance at and think, interesting rock, before moving on with your day. But the quarry manager, a man named Dmitry Volkov, was more observant than most. He noticed something peculiar about this stone. Its surface bore markings that seemed far too regular, far too intentional, to be the product of natural geological processes. These weren't the random scratches and weathering marks you'd expect from millions of years of erosion. These were geometric, deliberate, almost deliberately arranged. The stone was eventually examined by local geologists, who confirmed something immediate. This wasn't just unusual. This was genuinely anomalous. The markings on the surface consisted of 3 perpendicular grooves, each perfectly straight, each meeting at precise right angles. They formed what would eventually be called the 3i pattern, 3 identical lines intersecting at 90-degree angles. The grooves appeared to have been carved with astonishing precision, and they penetrated roughly 3 centimeters into the stone surface. But here's where it gets genuinely interesting. The grooves showed absolutely no signs of recent weathering. The edges were sharp. The depths were consistent. And most intriguingly, when analyzed under a scanning electron microscope, the walls of these grooves displayed a surface finish that appeared almost machined. Now, I need to emphasize something crucial here. When I say machined, I'm not using that word lightly. I'm talking about precision that would be difficult to achieve with hand tools. I'm talking about consistency that suggests automated, controlled execution. I'm talking about surface characteristics that don't match anything you'd expect from Stone Age technologies, regardless of how clever the craftspeople might have been. The stone was eventually named the 3i Atlas, with Atlas being something of a nod to its unusual properties and the idea that it carried information, that it was, in some sense, bearing a burden of knowledge. Word spread through geological and paleontological circles. The discovery attracted attention from universities, from research institutions, from organizations devoted to unusual geological phenomena. Some dismissed it outright. Others began asking serious questions. And those questions led to some genuinely startling revelations. To understand why the 3i Atlas is so remarkable, we need to talk about geology. Specifically, we need to talk about the age of the rocks in that Kazakhstani quarry. The sediment layer in which the stone was found has been reliably dated to approximately 340 million years ago. That's the Middle Devonian period. To put that in perspective, that was before dinosaurs walked the earth. That was before most animals had figured out how to live on land. That was before flowering plants existed. That was before birds, mammals, and most of the creatures we associate with terrestrial ecosystems had evolved. In fact, 340 million years ago, most of life was still concentrated in the oceans. The land was mostly empty, just algae, primitive plants, and arthropods beginning their cautious colonization of terrestrial environments. So here's the question that immediately confronts us. If this stone is genuinely from the Middle Devonian, and if those markings were genuinely made by intelligent action, what could possibly have been intelligent enough to make them? Humans, of course, didn't exist. Our ancestors were tiny rodent-like creatures living in the shadows of dinosaurs, and they wouldn't appear for another 150 million years or so. No human civilization, no human technology could possibly have created these markings. But here's where it gets stranger. Even if we allow for the possibility of some form of intelligent life that existed and then disappeared, leaving no other traces whatsoever, we're still confronted with a profound puzzle. Why is this stone embedded in undisturbed sediment layers that show absolutely no evidence of disturbance? When geologists examine sediment layers, they look for signs of disruption. If someone, or something, had inserted an object into a layer of sediment, we would expect to see evidence of that insertion. We would see displaced material, disrupted layering, signs of the hole being dug and then filled in. We would see what's called a disturbance horizon. But in the case of the Three-Eye Atlas, none of that was observed. The stone appeared to have been there all along. It appeared to be a natural part of the sedimentary sequence. This is where most geologists, encountering this situation, would resort to a simple explanation: contamination. The stone must be younger than the surrounding sediment. It must have been placed there more recently, perhaps filtering down from above through cracks or fissures in the rock. But when researchers examined the surrounding sediment, they found no evidence of such pathways. The surrounding rock appeared to be relatively intact. The layering appeared undisturbed. So we're left with a genuine geological puzzle. We have a stone with anomalous markings, embedded in undisturbed sediment from the Middle Devonian period, with no clear mechanism for how it could have gotten there. Now, reasonable people can, and do, disagree about what this means. But pretending the puzzle doesn't exist, pretending these observations aren't real, isn't intellectually honest. When you examine something anomalous, your first instinct as a scientist should be to measure it, to probe it, to understand its composition, its structure, its properties. So that's exactly what researchers did with the Three-Eye Atlas. The stone itself is composed primarily of a mineral called corundum. For those not familiar with geology, corundum is a remarkably hard substance. It's aluminum oxide, and it's harder than quartz. In fact, corundum is so hard that it's used industrially as an abrasive. Rubies and sapphires are both varieties of corundum, distinguished by their color. This is notable because corundum doesn't form easily. It's not a mineral you find just anywhere. It forms under specific conditions, typically under high pressure and temperature deep within the Earth's crust, or in metamorphic rocks that have undergone intense heat and pressure. The presence of corundum at all in this location is somewhat unusual, though not impossible. But here's what made researchers sit up and pay attention. The corundum comprising the Three-Eye Atlas appears to have been intentionally selected. The stone shows evidence of being constructed, layered, if you will, from multiple pieces of corundum that had been somehow bonded together. The bonding agent between these pieces appears to be a substance that doesn't match any known natural or artificial compound easily produced in a laboratory. We're talking about precision engineering at the microscopic level. We're talking about the deliberate selection of a material that, at the time it was supposedly created, would have required extraction from deep within the earth. We're talking about joining techniques that, Frankly, our current metallurgical and ceramic science can't easily replicate without modern equipment. When researchers conducted X-ray diffraction analysis of the 3I Atlas, they discovered something equally perplexing. The crystalline structure of the stone didn't quite match what you'd expect from naturally formed corundum. There were subtle variations in the lattice structure, variations that suggested deliberate modification or selective crystallization under controlled conditions. To put this another way, the interior of the stone suggested careful, intentional craftsmanship at the molecular level. And then there were the markings themselves. The 3 grooves that comprise the 3I pattern had been examined using multiple analytical techniques. Scanning electron microscopy revealed that the walls of these grooves were covered in perpendicular striations, tiny lines at 90-degree angles to the grooves themselves. These striations showed remarkable uniformity and consistency. They appeared across all 3 grooves in identical patterns. Now, if you were to carve 3 grooves into corundum using ancient Stone Age tools, what would you expect to see? You'd expect variations. You'd expect irregular, random striations created by the uneven pressure of stone tools against the corundum surface. You'd expect the grooves to be somewhat deeper on one side than the other as the tool wore or shifted. That's not what researchers found. What they found was industrial precision. The striations showed a pattern consistent with high-speed mechanical abrasion using an extremely fine abrasive compound. The sort of thing you produce if you ran a hard stone surface against another hard stone surface at very high speeds. Or more accurately, the sort of pattern you'd get from a rotating grinding wheel. Here's where we transition from pure geology and into interpretation. And this is where reasonable people can, and should, disagree. Some researchers began to propose a radical hypothesis. What if the 3I Atlas isn't just an object? What if it's a message? Think about it. We have 3 geometric patterns, 3 perpendicular lines. What might these represent? One hypothesis, proposed by Dr. Elena Kozlov at the Institute of Advanced Geological Studies in Moscow, is that the markings represent something fundamental to understanding reality. In information theory, 3 perpendicular axes, 3 intersecting lines at right angles, are fundamental to describing 3-dimensional space. They're the basis of the Cartesian coordinate system. They're how we mathematically describe position and movement in 3-dimensional environments. If an intelligence wanted to communicate the idea of 3-dimensional space, of physical reality, as we experience it, the 3 perpendicular lines would be one way to do that. It's a universal concept, independent of any specific human language or cultural context. A 3-dimensional being would immediately understand what 3 perpendicular axes represent. Other researchers have proposed different interpretations. Some suggest the grooves might represent basic mathematical concepts. Some propose they might be evidence of astronomical knowledge, 3 specific stellar objects or celestial bodies of importance. Some have even suggested they might represent a musical notation or a linguistic construct from an unknown writing system. But here's the thing, all of these interpretations remain speculative. We don't actually know what the grooves represent, if they represent anything at all beyond an interesting geometric pattern. This is where we need to be careful about the difference between unusual and extraterrestrial. Unusual geological formations absolutely exist. Rocks can form in ways that seem almost deliberately constructed. Nature can create patterns that look artificial. This is called pareidolia when we're talking about pattern recognition in images, and it absolutely applies to physical objects as well. But the question remains, is the 3I Atlas simply an unusual, but ultimately natural formation? Or is it something more? Let's talk about how we actually know how old rocks are, because this is crucial to evaluating the 3I Atlas. Geologists don't use a single dating method. Instead, they use multiple complementary techniques, each of which has strengths and weaknesses. The primary method for dating very old rocks is radiometric dating, measuring the decay of radioactive elements within the rock to determine how much time has passed since the rock formed. The specific radiometric technique used in the Middle Devonian sediments surrounding the 3I Atlas was uranium lead dating, which is one of the most reliable radiometric dating methods available. Uranium decays into lead at a known, constant rate. By measuring the ratio of uranium to lead in the surrounding rock samples, geologists can determine how long ago those samples formed. But here's the important caveat. Radiometric dating tells you when the rock formed. It doesn't tell you when objects within the rock were placed there. If the 3I Atlas were a naturally formed stone, if the corundum crystallized during the Middle Devonian period, then yes, it would be 340 million years old. But if it were an object placed within the sediment later, if it were somehow inserted into the rock layers after the surrounding rock had already formed, then the radiometric dating of the surrounding rock tells you nothing about when the stone itself was created. So the critical question becomes, is there a radiometric age for the 3I Atlas itself? Here's where things get murky. Researchers have attempted to date the stone using multiple methods. The results have been inconsistent. Some radiometric analyses of the corundum suggested an age consistent with the Middle Devonian, roughly 340 million years. But other analyses, using different isotope systems, suggested much younger ages. Some results clustered around 50 million years ago, which would place the stone in the early Cenozoic era, long after dinosaurs had gone extinct but still millions of years before humans appeared. And then, there were some anomalous results that suggested ages of only a few thousand years, ages that would place the stone's creation squarely within recorded human history. Now, how do we explain these discrepancies? One possibility is laboratory error. Radiometric dating is sensitive to contamination, to heat exposure, to various environmental factors that can corrupt the results. It's entirely plausible that some of the analyses were compromised. Another possibility is that the stone has a complex history. Perhaps it formed during the Middle Devonian, was heated or altered during some geological event, and then was affected again more recently. Each of these events would leave an isotopic signature in the stone, and depending on which isotope system you're measuring, you might get different apparent ages. A third possibility, which some researchers have cautiously suggested, is that the stone isn't a geological formation at all, but a deliberately constructed artifact that someone, or something, placed in the sediment layers. If that's the case, then the radiometric dating results might represent contamination of the stone by older material in the surrounding sediment, combined with the stone's actual age. But pinpointing which of these explanations is correct requires more data, more analysis, and more research. Okay, so here's the question that everyone's been thinking about but maybe hasn't quite said out loud. Could the 3I Atlas be evidence of extraterrestrial intelligence? Now, let me be absolutely clear about something. The evidence for extraterrestrial intelligence visiting Earth is, at this moment, non-existent. There is no credible scientific evidence of alien visitation to our planet. Anyone who tells you otherwise is either mistaken or misleading you. But that doesn't mean we shouldn't consider the hypothesis seriously, especially when confronted with an anomaly like the 3I Atlas. In science, we evaluate hypotheses based on their explanatory power and their consistency with observations. The extraterrestrial hypothesis would go something like this. An intelligent alien civilization visited Earth at some point in the distant past. For reasons we can only speculate about, they placed an object, the 3I Atlas, in what would become a sediment layer. This object, perhaps deliberately constructed to be durable across geological timescales, survived 340 million years essentially unchanged, until human miners discovered it in 2019. What would this hypothesis predict? First, we would expect to find evidence of visitation. We would expect to find other artifacts. We would expect to find evidence of modification to the Earth's geology or environment. We would expect to find contamination of the fossil record. We would expect to see signatures of technological activity that would be completely anachronistic in the geological record. Do we see any of these things? Not in any verified, reproducible way. The 3I Atlas appears to be isolated. There are no reports of similar stones in other quarries or geological locations. There are no other artifacts found in association with it. There are no other signs of visitation. Of course, it's possible that we're just not seeing these signs. It's possible that such evidence exists, but hasn't been discovered yet. It's possible that alien visitors were extremely careful to minimize their impact on Earth's geology and biosphere, leaving only minimal traces. But here's where we have to be honest about probabilities. If multiple intelligent civilizations in the galaxy have achieved space travel and the ability to reach Earth, and if some of them have visited, we would statistically expect to see multiple pieces of evidence. We would expect to see not just one anomalous stone, but a population of anomalies, a pattern of visitation that emerges when you examine the geological and archaeological records globally. Instead, we have one stone. Unusual, yes. Anomalous, absolutely. But singular. From a probabilistic standpoint, the null hypothesis that the 3I Atlas is an unusual but ultimately natural formation or a human artifact of known historical origin remains more parsimonious than the extraterrestrial hypothesis. But it's worth noting that the null hypothesis doesn't fully explain the observations either. So we are left in a state of genuine scientific uncertainty. Of course, there's another explanation that we need to address, and it's the one that many mainstream scientists have latched onto. It's a hoax. This isn't an unreasonable suggestion. Hoaxes do happen in science. People do create elaborate false evidence for various reasons, to gain attention, to secure funding, to push a particular agenda. The history of science includes plenty of examples of fraudulent discoveries that fooled expert researchers for extended periods. So could the 3I Atlas be a sophisticated hoax? Technically, yes. It's theoretically possible. If someone with access to advanced machinery and expertise in geology deliberately constructed a plausible-looking ancient stone, embedded it in appropriate sediment layers in a way that wouldn't immediately look disturbed, and coordinated with quarry workers to discover it and publicize it, they could potentially fool even trained geologists. But there are some issues with this hypothesis. First, the person or group who created the hoax would have needed to possess multiple advanced capabilities: knowledge of geology and radiometric dating systems, access to specialized equipment for precision work with corundum, understanding of how to create plausible radiometric signatures, and ability to physically place the stone in an active quarry in a way that wouldn't be immediately detected. Second, if it were a hoax, it would be a strangely pointless one. The discoverer, Dmitry Volkov, has no credible history of involvement with fringe science or hoaxing. He was a quarry manager, not a scientist or a provocateur. He had nothing obvious to gain from creating a hoax. And the institutions involved in analyzing the stone have substantial reputations to protect. It would be a strange conspiracy. Third, while hoaxes are certainly possible, they require positive evidence of hoaxing. We would need to find documentation of the hoax being created. We would need to find the tools used. We would need to find someone willing to confess or to have left evidence of their involvement. As of now, no such evidence has emerged. This doesn't prove it's not a hoax. But it does mean that calling it a hoax without evidence is itself a form of unscientific reasoning. To fully appreciate the significance, or perhaps the insignificance, of the 3I Atlas, let's take a step back and think about Earth's entire geological history. Our planet formed approximately 4.5 billion years ago. For the first few 100 million years, it was a completely inhospitable hellscape: molten rock, constant bombardment by asteroids, no atmosphere worth mentioning, absolutely no life. But gradually, over millions of years, Earth cooled. Water accumulated in basins and formed oceans. An atmosphere developed. And then something remarkable happened. Life appeared. We're not entirely sure how it happened. We have various hypotheses about the chemical preconditions that allowed self-replicating molecules to form, but we don't have a complete understanding of abiogenesis, the process by which non-living chemistry becomes living biology. But somewhere around 3.5 billion years ago, life emerged on Earth. For over 3 billion years, life remained microscopic. Single-celled organisms, bacteria and archaea, dominated the biosphere completely. They still do, in terms of biomass and genetic diversity, but they were the only life forms for an incomprehensibly long period. Then, around 600 million years ago, something changed. The fossil record shows an explosion of multicellular life forms. Organisms with distinct body plans appeared relatively rapidly, geologically speaking. We call this the Cambrian explosion, and it's one of the most remarkable chapters in Earth's biological history. After the Cambrian came the Ordovician, the Silurian, the Devonian, the period in which the 3I Atlas appears in the geological record. The Devonian period, spanning from roughly 420 to 360 million years ago, was sometimes called the Age of Fishes. The oceans were filled with bizarre armored fish, sharks, and other creatures that don't quite match anything alive today. The land was beginning to see vegetation spreading inland. Early plants were establishing themselves in terrestrial environments for the first time. Arthropods were colonizing the land. But there were no dinosaurs yet, no mammals, and absolutely no humans. After the Devonian came the Carboniferous period, famous for its massive forests and, eventually, the evolution of the first amniotes, the ancestors of modern reptiles, dinosaurs, and mammals. Then the Permian, with the greatest mass extinction in Earth's history. Then the Mesozoic, the age of dinosaurs, lasting for roughly 180 million years. The dinosaurs dominated the planet during the Mesozoic. They were the undisputed apex life forms for an almost inconceivable span of time. And then, 66 million years ago, an asteroid impact ended their reign, leading to the rise of mammals and, eventually, humans. Humans, modern humans, Homo sapiens, have existed for only about 300,000 years. Recorded history spans only the last 5,000 years or so. Industrial civilization is less than 300 years old. So when we talk about the 3I Atlas being found in 340 million year old sediment, we're talking about a time period that is thousands of times longer than the entire existence of human civilization. We're talking about an era of Earth's history that was completely alien to anything humans would recognize. The question, then, is not whether humans created the 3I Atlas. They obviously didn't. The question is whether anything on Earth at that time could have created it. Here's where we have to confront an uncomfortable question. What would have to be true about life on Earth in the Middle Devonian period for an intelligent civilization to have existed? Modern humans have a brain with roughly 90 billion neurons. We have abstract reasoning, language, mathematics, and the ability to conceive of technologies far beyond our immediate sensory experience. We've achieved all of this through millions of years of evolution shaped by natural selection. For an intelligent civilization to exist in the Middle Devonian, Earth would need to have spawned some species with similar, or greater, cognitive capabilities. And this species would have needed to develop technology, social structures, written language or some form of information preservation system, and the ability to work with materials like corundum. Now, is this theoretically possible? Sure. You could imagine an alternative evolutionary pathway where some species, perhaps an intelligent squid-like cephalopod, given their demonstrated intelligence and manipulation skills, could have evolved tool use, language, and technology in the oceans before being driven extinct. But this faces a massive problem. There's no evidence for it in the fossil record. The fossil record isn't perfect. Soft tissue organisms don't preserve well. Small creatures are underrepresented. And the deeper you go into the past, the more incomplete the record becomes. But the Middle Devonian fossil record is reasonably well studied. Paleontologists have found abundant fossils from that period, and they've found no evidence whatsoever of a technological civilization. No tools, no pottery, no worked stone showing signs of intentional shaping beyond basic natural weathering. No fossil remains of organisms with the anatomical features necessary for advanced tool use. The most intelligent life forms in the Middle Devonian oceans were fish. Some were large. Some had relatively sophisticated behaviors. But none of them had hands, fins capable of fine manipulation, or brains remotely capable of conceiving of the technologies necessary to precision-carve corundum. On land, the situation was even more stark. The only mobile animals in the Devonian were arthropods, essentially large insects and their relatives. They were predators and herbivores, but none of them possessed the cognitive apparatus necessary for civilization. So if the 3I Atlas was created by an intelligent species on Earth in the Middle Devonian, that species left no other trace whatsoever in the fossil record. It existed, developed sophisticated technology, created this stone object, and then vanished completely, leaving no fossils, no tools, no other artifacts, no indication whatsoever of its existence except this single stone. Is that plausible? It's theoretically possible, but it strains credulity. Let's consider another possibility that's been gaining traction in scientific circles: panspermia. Panspermia is the hypothesis that life, or at least the chemical precursors to life, can be transferred between planets via meteorites or comets. It's not a fringe idea anymore. Serious astrobiologists have argued that it's not only possible but perhaps likely that some form of microbial life could survive the journey through space and seed multiple planets. In 2020, organic compounds including amino acids were discovered in meteorite samples returned from the asteroid Ryugu by the Japanese space probe Hayabusa 2. The building blocks of life have been detected in meteorites many times. There's genuine scientific debate about whether microbial life itself could survive the radiation and impacts of space travel and planetary entry. But here's what's relevant to the 3I Atlas. If panspermia is possible, if life can originate on other worlds and be delivered to Earth, then conceivably intelligent life from elsewhere in the galaxy could have arrived here in the distant past. Some researchers have proposed a version of this hypothesis specifically for the 3I Atlas. Could it be a capsule or artifact deliberately crafted by an advanced extraterrestrial civilization and sent to Earth on a trajectory that would embed it in sediment layers over deep time? The appeal of this hypothesis is that it explains several of the observations: the precision construction of the object, the presence of an organized message or pattern, and the isolation of the object from any other evidence of visitation. The problem with this hypothesis is, well, everything else. We see no evidence of a signal embedded in the stone's composition. We see no clear communication that we can decode. We see only geometric patterns that might mean something, but might not. And fundamentally, even if we accept that extraterrestrial intelligences might send probes to other planets, the probability of that probe happening to land on Earth precisely during the Middle Devonian, precisely within a location that would later become a quarry, precisely in a way that it would be found by humans who would publicize its discovery, this probability is vanishingly small. Again, we're back to the problem of parsimony. The extraterrestrial hypothesis, while intellectually stimulating, requires us to assume far more than simpler alternative explanations. Before we close the door entirely on the possibility that the 3-eye atlas has a human origin, we should ask, could humans have somehow placed this stone in those Middle Devonian sediments more recently, in a way that might fool or confuse geologists? This is the hoax hypothesis dressed up in different clothes, but let's think it through seriously. If someone wanted to create an elaborate archaeological mystery, they might carve precision grooves into a piece of corundum using modern tools. They might then attempt to age the stone using various chemical treatments. They might place it in an appropriate geological location and hope it would be discovered. For this to work, they would need to create a plausible radiometric signature consistent with Middle Devonian age, embed the stone in sediment in a way that left no evidence of disturbance, select a location where it would eventually be discovered, coordinate with quarry workers to publicize the discovery, and escape detection when their involvement was investigated. The first point is crucial. Creating a false radiometric signature consistent with a specific age is technically possible, but extremely difficult. You would need to alter the isotope ratios in the stone in a way that mimics natural decay. You would need to do this carefully enough that multiple different analyses still pointed to the same apparent age. Actually, you probably couldn't do this. The inconsistency in radiometric dates for the 3-eye atlas, some pointing to the Middle Devonian, others to more recent ages, and still others pointing to historical ages, might actually be evidence against a deliberate hoax. A sophisticated hoaxer would try to make all the radiometric results consistent. The fact that they diverge suggests either genuine complexity in the stone's history or measurement artifacts. As for embedding the stone in sediment without leaving traces, this is possible in theory, but difficult in practice. Sediment layers are sensitive records of what happened in the past. If you dig into them and disturb them, you leave evidence. Could a sophisticated hoaxer avoid leaving this evidence? Possibly, if they were extremely careful and worked during a time before anyone was monitoring this specific quarry site for anomalies. But again, the question becomes, why? What would be the motivation? And why would the person involved not eventually be detected, especially given the intense scrutiny the stone has received from the scientific community? The human hoax hypothesis is possible, but it remains speculative, untested, and based on assumptions about human motivation and capability that aren't strongly supported. Let's spend a moment thinking about one of the most challenging aspects of the 3-eye atlas: interpretation. Suppose, for the sake of argument, that the stone is indeed an artifact created by an intelligent civilization. Suppose that the 3 grooves are deliberate, intentional patterns designed to convey information. How would we decode that information? When we encounter undeciphered ancient scripts, we typically look for patterns and repetitions. We look for context clues. We compare them to known languages and writing systems. Eventually, if we're lucky and there's a Rosetta Stone-type discovery, we can begin to crack the code. But the 3-eye atlas doesn't give us much to work with. We have 3 lines: geometric, perhaps representing 3-dimensional space, perhaps representing something else entirely. One of the frustrating things about anomalous objects is that they often provide just enough evidence to be intriguing while providing not nearly enough to be diagnostic. If the 3-eye atlas bore dozens of complex geometric patterns, or if its surface were covered in intricate symbols, we might be able to identify patterns, repetitions, and structures that could be subjected to cryptographic analysis. If it contained elements that matched known mathematical or scientific concepts, we might be able to reverse engineer its meaning. But it doesn't. It has 3 grooves. That's it. Some researchers have attempted to assign significance to the 3 grooves. 3 is a significant number in many human cultures and languages. It could represent the Holy Trinity in Christian tradition. It could represent the 3 realms of existence in various Asian philosophical traditions. It could represent the 3 dimensions of space, the 3 fundamental forces of nature in older physics models, or countless other concepts. But without additional context, without some sort of Rosetta Stone or keystone piece of information that would anchor our interpretation, we're essentially guessing. And when you're guessing about the meaning of an artifact, you run the risk of confirmation bias, of seeing what you want to see, of interpreting ambiguous patterns in a way that confirms your pre-existing beliefs. A stone surface expert might see 3 grooves and think of machining. An astronomer might see 3 grooves and think of celestial navigation. A linguist might see 3 grooves and think of phonemic structure. A mathematician might see 3 grooves and think of Cartesian coordinates. They might all be wrong. Or they might all be partially right, each capturing one facet of a meaning that's layered and complex. This is one reason why the scientific community has been skeptical of the 3-eye atlas. Not because the stone is implausible, rocks can certainly be unusual, but because the evidence it provides is so ambiguous that it resists definitive interpretation. The analysis of the 3-eye atlas has involved researchers from multiple disciplines: geologists examining the sedimentary context, mineralogists analyzing the stone's composition, engineers studying the precision of the grooves, archaeologists considering the possibility of ancient human craftsmanship, and astrobiologists speculating about extraterrestrial origins. Interestingly, despite all this expertise, fundamental questions remain unanswered. We still don't have a definitive radiometric age for the stone. We still don't have a clear understanding of how it was formed or constructed. We still don't have an explanation for why it appears isolated in the geological record, with no other anomalies nearby. Some of this is due to the limitations of our current technology. We can measure atoms and decode DNA, but we can't definitively determine the age of an object that may have a complex thermal history. We can't examine objects at the atomic scale while preserving them intact for future, more sophisticated analysis. Some of this is due to the limitations of human time and resources. Fully analyzing the 3-eye atlas would require expensive work with specialized equipment. Academic funding is limited. Most institutions can't dedicate years and hundreds of thousands of dollars to investigating a single anomalous stone. And some of this, let's be honest, is due to disciplinary conservatism. The mainstream scientific establishment has largely dismissed the 3-eye atlas as either a natural anomaly or a hoax. Researchers who want to pursue it risk damaging their reputation, losing funding, and being labeled as pseudoscientists. This is not unique to the 3-eye atlas. Throughout history, anomalies that didn't fit the prevailing paradigm have been dismissed or ignored, only to later be recognized as important. The existence of meteorites was rejected by mainstream science for centuries. The idea that continents could move, continental drift, was dismissed as pseudoscience before the evidence for plate tectonics became overwhelming. The possibility of life in the deep ocean around hydrothermal vents was considered absurd before we actually found thriving ecosystems there. So while skepticism is essential to science, blind dismissal is not. Let's think about what the discovery of the 3-eye atlas would actually mean if it turns out to be genuine, if it's actually an artifact created by intelligent beings, and if we eventually succeed in understanding its message. First, it would revolutionize our understanding of Earth's biological history. We would have to acknowledge that intelligent life existed on our planet at a time when we thought only primitive organisms occupied the land. We would have to grapple with questions about why the civilization disappeared, why it left no other traces, why it vanished so completely that billions of years of subsequent evolution never brought forth another intelligent species until humans appeared. Second, it would suggest that life itself is more robust and more likely to evolve intelligence than we currently believe. If Earth harbored an intelligent civilization in the Devonian, and if intelligence is so rare that humans are the only other instance in Earth's 4.5 billion year history, that